Okay, hello. Yeah, so I did a stream this morning and I was talking about how you can do mutable state externally from React, but not breaking its paradigm of value comparison so that you can do use memo and use callback and use effect and all of that, like still in React, even though you have mutable references. And it all seemed like a good idea because it removes this influence from the UI as you're building up your state management. Like you really want to not think about UI when you build external state management, but it's very, very easy to get into the trap of, oh, I'm going to use a computed here because this UI needs all this derived state and I want to cache it, so it's like super optimal. But React is the responsible part for UI, and you don't want to dictate how the UI is going to be implemented by how your state is exposed. So you kind of want to have very generic, kind of like an API, right? If you build a server API, you don't want to dictate. You don't want to create endpoints of derived state, right? You expose the data or the state as is, and then it's up to the client to fetch what it needs at any moment in time. It's kind of the same thing. But the problem that was pointed out is by doing this, we lose the benefit of that is mutable external state management. Oh, sorry. State management. So you have this mutable state management, right? And then you have some components. Doop, doop. So you have this component tree. Can I just do this? Yeah, whatever. So these are children, right? And then even though you choose to pass this mutable state management to like the root, you might pass like the full state down here, and then you pass like state.nested down here, and then you might even like pass state.nested down here if you want to do that, and then inside here you do state.nested.count, for example, right? And the benefit of doing mutable state management is that you can just point to state.nested.count in your mutable state management, and by doing so, this is the only component that's gonna reconcile. That's an amazing thing, right? So the alternative, like if we had an immutable state management, what would happen then is that it would first render root or reconcile root. It will reconcile this one, and finally reconcile this one. And this is like the flow of React, right? Top-down flow. Or, yeah, I guess that's what you call it. Oh, fuck. It's the school calling, but my just 2 seconds. Oh, sorry, I got distracted. I wasn't sure what I wanted to do. My partner has her day off today, so I was hoping she could take the call, but I should probably have taken it. Just 2 seconds. I just need to. Oh, God damn it. There's always something. Hopefully, nothing has happened. Reasons. Okay, I'm just gonna call back to our daughter's school. Just 2 seconds. Hallo? Hei. Hvordan går det? Jeg vet ikke om mamma er akkurat nå. Jeg har sett melding til henne. Men hva var det da? Gå hjem selv nå? Ja, det går bra det. Jeg er nede i kjellerne. Mamma kommer nok snart. Skal du rett til Line? Ok. Ja, ja, men det er greit det. Så lenge vi vet hvor du er, så velger du det selv. Kom hjem da, hvis ikke du kan være hos Line. Greit. Ja, det... Sorry. I use sometimes like it might have been important. It wasn't important. Anyways, where were we? Yes, and when it's immutable, it's gonna reconcile. Now, the thing is, with current React, what's more like the truth here is like, you probably have like something like this, right? And then, just to make the point clear, you have immutable state management. It flows from the top. It reconciles all of these components correctly. And maybe like you have this and you have this. Oh, 2 seconds. Hello? Hei? Du, jeg jobber her med. Du kan ikke bare ringe meg sånn. Hva er det? Hæ? Nei, men det er greit. Du bestemmer det selv. Du kan ikke tvinge deg. Ok, greit. Sorry. Ha det. Oh my god. Anyway, so it might look something like this, right? So the reality is that when you make this nested change, it reconciles like all of this stuff, right? But with the React compiler, it would, as I understand it, it would actually guarantee that it only reconciles these ones. And the question is that good enough? I can't. Okay, what am I trying to say? I think I'm thinking about two different things. One thing is like, will the React compiler actually fix all the issues? That's one thing. That's an open question still. But if you were to do mutable state management and to take advantage of that state still behaving as normal state in React, which I think is important. Like the alternative is that you have to expose like very special hooks. Damn it. This got messy. Sorry. So for example, you want to derive some state, right? So the idea was, okay, we're going to make the mutable state be compliant with value comparison so that you can use memo whenever you need to derive state and kind of cache it for the components. But then you lose this ability to like target specific components for reconciliation. That's like the amazing thing about it. But every component has its observer wrapper, right? So what if you didn't do that? You rather subscribe to your mutable state management at the root. And then whatever nested updates happens, you just reconcile again from the top. And then it will just do the normal like value comparison to figure out what components needs to render. And that works perfectly fine with the React compiler. But the question still stands. Is it fast enough? And then, okay, flip it around. No, we're gonna keep like targeted reconciliation, but now we need like a new hook. Like we need a use reactive hook or something. Use reactive memo, whatever. Use derived, use computed, call it whatever you want. But that only works with actual reactive state. It doesn't work with the other state in your components. So it just gets really messy. So I think it should absolutely not merge those worlds. It's perfectly fine to have mutable state management externally, but it should behave as a mutable state inside React. That is important. But doing that breaks the one insanely awesome performance benefit of mutable state. And that is the targeted reconciliation. Because if we're gonna allow you to use that state for use memo and use effect and whatever, it needs to act as a mutable state, which has this side effect of, okay, but then we also need to reconcile everything. Well, you don't have to. Like, this is the thing we discussed in the stream. It's like, okay, I can change the count and I'll change the references for state nested. So it changes its reference, but it still only reconciles this component. The problem though is if later maybe I change some state here inside this component, and because I changed state there, it's suddenly gonna reconcile this one and this one because they've changed reference, but we didn't force React to update them. And that's even more confusing. Yeah, it's very annoying. It's very, very annoying. So what's left? So I don't think it's possible. So it doesn't make sense for targeted reconciliation. So given that the React compiler makes React performant enough, then it's fine. So I think that's what I'm trying to get at. We're just going to assume that the React compiler makes React performant enough. And then it's more a question of would you prefer doing your external state management? Do you even need to do external state management? Because if React is performant enough, can't you just use state and you just create your hooks? Like if you want to share some state, you create some hooks at the top here and just pass state down, right? And you don't have to use callback, you don't have to use memo, you can just naturally like just expose everything. But then again, you're still in this situation where, okay, you have a list of things. So you use a use state to create a list of to-dos, for example. And then you're gonna update a completed state of a to-do. So what you have to do is, for example, just having that to-do component, you have to pass down the ability to toggle it as a function and the to-do itself, of course. So in this example, you would probably have to like pass down state.nested and the specific to-do, so that you can access the function that's actually going to toggle the to-do. Because that's the thing about React, is that you can't do nested state. Or, well, okay, maybe that's not true. Like, so what you can do is like you have a to-dos list, and in that to-dos list you iterate the data, right? the actual data coming from the server, but you want to encapsulate that data with some functionality. So you create a hook called like use to do, and then you pass it to do DTO, right? And back comes, well, you can't really do that because you can't like use a hook dynamically, right? So that kind of feels very unnatural in React. As long as you're using like a primitive value in use state, it's fine. But as soon as you start putting an object or an array in a use state, it starts getting icky. Because having like a number in use state, like a count, and then you have like increase as a separate function, all that makes sense. But if you have an object or an array of objects, you still have like maybe add to do as a separate function, but you want to toggle completed like on the specific, like there's this separation of state and functionality. And maybe that's fine. Maybe that's just how it needs to be. It's not that it's like wrong, it's just less discoverable. And you have to do a bit more boilerplate stuff. Because you have to, it's almost like if you think about passing props, you have to pass two props. You have to pass the state prop and the functions prop, right? Well, of course, you could do use to do inside the to do component. So you pass the to do DTO. And then you have to do DTO, right? And then you have use to do. Yeah. Yeah. Maybe we should play around with that instead. Play around with the React compiler. But again, this is like you are adding complexity to. So what I'm trying to find is like a reason, like let's say the React compiler fixes all performance issues. There's no reason to choose external state management because of performance when you have the React compiler. So like doing things like this makes sense for React, but there's also a world you can create for React where you just get the to do here. And it has like toggle completed. Like it has all the functionality on it. There's no like orchestration of like creating hooks and orchestration of passing state and functions separately and all of that stuff. It's all just there. And that's a very pleasant thing to work with when your main consideration is the actual UI. Yeah, I'm having a hard time getting to any like conclusion here, or even the next step. Well, I guess one conclusion is, if you're going to do external state management, regardless of how you do that, at the end of the day, when it's consumed in React, it needs to behave like React, as if the state was defined in React. So with that in mind, like this Bonsify project, it has this simple reactive primitive. It needs to work like, instead of having these observers around all the components, I think that's more valuable to explore. Like changing Bonsify to be like this top subscription. And whenever you mutate something in that state tree, and we don't need read-only anymore, because by subscribing, it actually makes it read-only. Yeah, to still have that, and then it handles value comparison, and then whenever you change something, it will cause this like waterfall reconciliation, but we're just going to test it with the React compiler and see what actually happens, and see like how optimal it is. Yeah, I think that's what we're going to do. Let's see. I'm kind of pumped writing some code for this. Let's see if I can. Yeah, let's do it. Let's write some code for this. Let's see. So we're gonna change this quite a bit. So let's create a branch of this first. Top level notify. So we don't need our observer anymore, in the sense that how are we gonna do this? So when we subscribe, are we gonna create that object? Okay, what I think we're gonna do is, on this reactive, we're gonna change read only to subscribe. Yeah, we're gonna change it to subscribe. Excuse me, I have a cold. Let's see. So we're gonna change this to subscribe. But when we come on, subscribe, so we're gonna pass in the, yeah, this is gonna be great. Oh my god, fucking snot. You have to excuse me, I'm disgusting. We're gonna give it a callback, and this callback is gonna be the notifier. Yeah, notify, and it's gonna give a snapshot, which is just a number, and it doesn't need to return anything. Let's just think about how we would actually implement this. So we would use sync external store. Do we need to use sync external store? I don't think we need to do that, because we're gonna have a top level subscription. We need, because then we also need to get the current snapshot. Like the risk is like, what if you like use this state at the top and then and while it's reconciling it, the state changes, like during the initial reconcile, or like right after initial reconcile, before, like there's a moment in time that React considers itself done doing the reconciliation, and there's some async stuff happening there. So there could be a state change in between that. And that would be kind of bad, like on the initial render, to have like state changes, because then it just has to start all over again. That's a different issue. Yeah, no, you know what? I feel like I'm getting stuck all the time here. I think I'm gonna drop out of the stream and think about this more. I'm not feeling it. I'm not feeling it. We'll give it a couple of more minutes. So the problem is, with using external store, we're gonna subscribe. But it's not only subscribe, it's also something called get snapshot. Basically, React might reconcile the whole thing, like build up the whole component tree, and then there's like something that happens inside the state store, and then as React kind of completes the process and starts subscribing, it checks the snapshot again, and if that snapshot has changed, it's gonna do the whole thing again, which doesn't happen if you just use React. Yeah, maybe my time is better spent like writing state management for React with the React compiler, because it does change things. Maybe it's not performant enough. It will be more performant, that's for sure. But again, yeah. Yeah, it is very interesting. And only to be able to do like mutation. Not having to do the set state callback, spreading objects and arrays and all that stuff. But you do have, okay, so one thing that's interesting, I use Immer. What's that? Become older. Yeah. Like you still have to use that callback, but that's fine, right? Like it's almost like React could have a hook called use mutable state, and then in the callback you can just use plain JavaScript to change the object. So if that's the argument that you wanna, no, you need to go external because you want to do a mutation-based API. You could just use Immer, right? Hmm. Yeah. No, I'm not getting anywhere. Sorry. I'll probably just ah. Wouldn't it be much better to rather embrace React for what it is and then rather find good patterns that helps you organize your code in React, make it readable, how to handle like async complexity, stuff like that, as opposed to like finding this like external primitive. But there's some subtle benefits, right? One thing is just to be able to think in just using the language, like literally just using the language, no callbacks to update state or anything like that, no drafts, no immutability you have to think about, just expressing the thing. And then doing async stuff is like, no worries, just do it. Because that's also a really painful thing in React. Like you have to abort all promises or abort all async processes. Well, do you really need to do that? That's also interesting because if you define your state on the root, right? And like, yeah, you also alleviate that problem because if you have, for example, a mutation running, maybe even use React Query for that, but if you were to like run a custom mutation or just like doing something async, you would do that like higher up in the component tree. You wouldn't bind that to like local state. That would happen further up. I guess you could still go wrong though. Couldn't the reactive proxy that it generates call sync external store for the component for which it defined? Okay, I like what you're trying to do. Like, let's take that perspective. We got so close, right? We had the targeted reconciliation, but then it kind of broke because we because of props passing. Like, you would have this potential lazy reconciliation because you're changing references, but you're not actually triggering React to respond to those reference changes until something else causes a new check for reference changes, and then maybe the change we did before is in the path of that new reconciliation. But what if there was a way to handle that? Couldn't the reactive proxy that it generates call sync external store for the component for which it's defined? Yeah. Yeah, I think the problem. Okay, sorry, I had to think a little bit. So the problem is if this nested component is like a to-do and you're toggling it, and you might have like something up here that is like deriving something from, like, for example, okay, that's a perfect example. You have the to-do app, right? And then you're looking at uncompleted. You're filtered on uncompleted to-dos, right? And then you complete one of those to-dos. So higher up in the component tree, you want to it needs to refilter the list, right? Yeah, but that yeah, what am I saying here? So you would have all these subtrees and they render from the roots. If you change nested state, you modify the reference. Create new. Oh, so you're saying each reactive represents its own set of proxies? So like, so when you call reactive, you kind of create a tiny little state tree. And when you make a change within that tiny little state tree, only that reactive reference actually updates. Computing. How would that change things? I still think there will be a problem with the toggle completed example. So what if I have a reactive which represents the list of to-dos, and I'm running that in a component, and then for each to-do I have a reactive. And then I have a filter. I'm deriving the to-dos list based on, well, but then I'm actually looking at each to-do. So they are kind of part of the part of the thing. Okay, so that will work because that filter is actually looking at every to-do. So it would be kind of, yeah, it would observe all of them. And that means, oh shit, I'm having a hard time computing this. What was the original problem? Yeah, so we were changing this one, and then we were changing references up to 3. Yeah, I think I'm forgetting one factor here. It's the fact that the only thing that actually cares about this count is this component. But yeah, so if, okay, so let's imagine that. What if you had, like, for some reason in this component, you were using memo on state.nested. Yeah. So we had this example of, we were listing a bunch of to-dos, and then when you toggle a single to-do, that would change its reference, but it would also change the reference of the actual list of to-dos. But it would only reconcile the actual component that changed its toggle state. But then when you change the input to create a new to-do, it would actually reconcile the list again, and then it will reconcile the toggle to-do again. Just because the nested, or the specific to-do object had changed its reference. But if that to-do was its own reactive thing, it would only change itself, and it wouldn't change reference on the array. Yeah, I'm trying to find, because what's interesting to me is, okay, so this is the interesting thing. Let's extend that example with something concrete. So what if we don't go up and change? No, that doesn't make sense. Okay, anyways, so in the to-dos list, hello there, I'm stuck in my own brain. So you'll have to excuse me, I have a hard time thinking through this. But let's extend the example with the to-dos list. So you're not only having a to-dos list, you also have a filter. So you have a use memo. Let's write this down. So we have function to-dos list, right? And then we're getting the state from here. Okay. Keep it coming, Adam. So if the to-do define its own reactive, then only the incoming props would change the parent's reactive. Yeah, okay, but let's take that uh, thank you, I guess. You'll have to excuse my voice, by the way. I'm recovering from being sick. So we have this to-dos list, right? And the to-dos we're gonna show is a use memo of state to-dos. Because we're gonna filter them, right? Or maybe we're gonna even do like object values, state to-dos, and then we're gonna filter them based on, like, I just have this local filter here, right? Whatever, right? We're just gonna filter the thing. So that's like completed or whatever. Oh, look at this. Oh, didn't I did JSX. Why are you complaining? Oh, yeah, whatever. So if we are toggling, and then we have to-dos, but they're like, they have their own component, and we're passing the to-do in there. And then that to-do has its own reactive proxy. And you're going in and you're toggling the completed state. And you're currently looking at active here, right? So if toggling that reactive, like toggling that completed state should trigger this memo. That's my point. But the thing is, if that's how it should work, right? But even if we do just like a targeted reconciliation for that, and we still change the references. We still change the references, but we don't trigger like a notification. Like, it doesn't reconcile just because we like flip out the references up the tree. It only reconciles the specific component. But in this case, the reason it renders is because this filter is actually accessing every single to-do, right? So it's looking through every to-do here, and it's checking its completed state. To-do dot completed. Yeah, whatever. So let's say that the filter is just, well, it's checking the actual filter. Like, there's some logic to this, but the point is that the reason this component reconciles again is not because when you toggle the nested item, we went up and we notified all observers of everything. All observers of each parent state, that something changed. It reconciled because this to-dos list actually looked at the state. And what am I thinking here? Okay, maybe another example would be like, maybe you had an add to do here. Maybe that's a better example. No, because that's the same. So if you add a to do here, the reason this to-dos list is reconciling again is because it's looking at the to-dos. I'm trying to find... So why are we removing the references? Or, yeah, removing the references of the parents. Like, none of these examples actually requires us to remove the references of the parents. There's something I'm missing here. I just need the actual example. I guess it would be... Yeah, what is the example where it would actually break? As long as we change the reference of the thing we're changing, are we fine by just doing that? Maybe that's actually enough. Because maybe that is kind of the same thing. Because what actually happens here is when I toggle the completed, there are two observers. Yeah, exactly. That's where I was going, Adam. What actually happens when you toggle the completed inside the to-do is that it's going to notify the to-do component itself, and it's going to notify the to-dos list, because the to-dos list is also looking at that specific... Yeah, but that's where it breaks. Yeah, exactly. That's exactly where it breaks. Because even though this one is notified, it's not going to run the memo again. Because we didn't say that the to-dos changed. We just said that the single to-do object changed its reference. That's the problem. But if toggling that to-do, we say that, okay, the to-do changed its reference, to-dos changed its reference, it would still notify to-dos list and to-do, and the reconciliation would just work as normal, and it would actually update the memo because this one has changed its reference. But the thing that could happen is if we just did this, we didn't actually look at each to-do, and then we toggled it, right? So we're not... So when we toggle it now, we toggle the actual to-do item, it reconciles the to-do component, but it doesn't notify to-dos list because it's not observing that specific each to-do and their completed state, right? So what happens now is that nothing happens. Yeah, which is fine in this case, because it doesn't care about the state. There's something about this. Like, if it doesn't explicitly care about the state, does it really matter if we reconcile or not? Right? Because if it looks at the state, that's when it actually needs to reconcile. But what... Yeah, but what's gonna happen here, which is kind of weird, is... What if I change the filter for some... Yeah, I'll change the filter. Or something else happens. And now to-dos has changed. So it's gonna go and grab the object values again. Oh, this is so mind-bending. Which is also completely unnecessary. Because it's not actually looking at the things. Yeah, which is why you want like a reactive memo or computed, because then it just works. But then you also have to know Yeah, like there's just this very implicit relationship between these two, which is like this thing is gonna reconcile. Yeah. Okay, so the weird thing that happens here is that it's not actually using status.todos for observation. It does that, but also the first time the memo runs, it also observes each to-do's completed state. So that's like, yeah, you know what? So this will be a problem. So this explains it better. So that's fine, right? But what's gonna happen the next time this renders is that it's gonna stop observing the completed state. Because the next time this renders, for whatever reason, like some other state change, it's gonna reconcile this component. And what's gonna happen is that it's not gonna run the memo again, because the to-dos has the same reference, which means that it's not gonna be looking at each to-do completed anymore. So if you toggle it, it's not gonna work. Yeah, so you definitely have to, if you're gonna do this, you have to like reconcile. Like there's two ways to do it. Either it needs to notify observers up the tree. So it's either that, or you can just subscribe to the root and then it will kind of reconcile from that instead. Yeah. I feel pretty confident about that. It doesn't seem like it, but yeah. You're gonna have weird behavior. But then what would be the most beneficial way to approach it? So what's interesting though is that you could also, okay, but let's just continue talking, because what you could also do is like, so we're changing this completed state. Let's see, we're changing this. Oh, there was a count there. Okay, let's just keep this in as a framework for our minds. So we're changing the completed state of a single to do, and what happens is that we're notifying the component that's observing that completed state of that specific to do. And then we're gonna go up. We're going to go up the component, the state tree. And then we're gonna, for each object and array in the state tree that actually has an observer, we're gonna change the reference and notify, right? So that's another thing we can do. That is like a hidden feature. We don't have to diligently remove the refs up the tree, the state tree. We only have to do it if that object or array actually has an observer. So what does that mean? That means that in the case of toggling the completed state of a to-do, it's gonna toggle that thing and the to-do gets a new reference. You know what would be very interesting? It's like the order of notifying observers. So let's talk about that. So what if first we notify the to-do component, but then we also notify the to-dos list component, right? Because there's an observer to the actual to-dos. Yeah, whatever. Okay, so we're gonna do that. So what's gonna happen is that there's gonna be like two two usync external store updates. And that's correct in this scenario. But we could also flip it around. So instead of notifying the to-do first, we can notify the to-dos list first. Does that matter? Well, how does React behave when you do multiple, like synchronous state changes in a like usync external store? Like it's subscribed, like you have two components subscribing to the store, and then you're making a use state on both of them. Like the point is, would it reconcile to do twice? That's the whole question. What two things are mismatched, Adam? Sorry, you have to excuse me. I think you have to, when I see your comment, I'm kind of further along, so it's a bit difficult for me to bring in the context you had when you wrote it. But yeah, regardless of, like, to finish the thought I was on, like something, if you're like passing nested state down, there will always be observers of, oh, sorry. Another thing that's very interesting is that yeah, so with the top level subscription, yeah, but I think that's the thing. Like, yeah, I guess that's the kind of, those two ideas is like, okay, you start at where the change happened, and then you kind of just walk up the tree, the state tree, and then trigger reconciliation where you have observers of the state. But you will have, like, to be able to access, like, to be able to make a change to like a nested state, you would have to access its parents, right, to even get there. So there are always observers. So you could trigger like the observers up the tree, or since you're gonna go up to the top anyways, and to be able to reach that nested state, you had to start from the top, you might as well just notify the top and let it do its thing. Oh, you're on the, yeah, reactive thing. Yeah, so you mean like, so if you change, but then if the to-do is a reactive and you make a change to it, do you think it should stop at the to-do? Or should it like walk up to the parent reactive? Because the parent reactive of a to-do is the actual to-dos list. Yeah, because I was also thinking about, like, there's a difference between, state that can change, like can have added and removed keys, and state that doesn't have that ability. Arrays typically like changes its indexes, of course, but an object, there's two types of objects. For a to-do, for example, you have certain properties there and they will never change. Like the keys will never change. So you don't listen to the you don't care about observing the object itself. You're observing access to the specific properties. But then if you have a lookup record of to-dos, you will be adding and removing properties from that object that you want to observe. But there's also something about that in terms of yeah. But don't you think it would be hard to reason about? Like you would have to understand how using these reactives externally affects how components render. Like, couldn't you easily get stuck in something not working? So you would kind of have to understand the relationship between the states, where you would determine how many reactives you would use based on like how one affects the other in terms of how you like look at it. So for example, you would choose how many reactives you would nest based on, oh, I have this completed state in a to-do component, but I also have the to-dos list, and by the way, that to-dos list depends on the completed state, so I want to do like a single reactive there because they care about each other. There's a relationship there. I like, it makes sense. I think you could easily get into problems. Do you have some code, Adam? I'm trying to put this in my head. I don't understand how short-circuiting a to-do with a reactive would always work if the parent depends on state. Yeah, the example of like, if you were using a memo up here for the to-dos and it relies on the completed, and then for some reason this component renders again, which means that you won't be actually looking at the completed state anymore because it's been cached, like use memo. So it only looks at the to-dos. So it only cares about if to-dos are added or removed. And then you do the completed flip in the nested component. And since that's a reactive, it's gonna only reconcile. It's only gonna reconcile that component. It won't jump up to the reactive of the actual list and actually render it again and filter it. Okay, cool. Yeah, it would be ideal to have that like perfectly optimal reconciliation. But still change the Okay, so I'm looking at what Adam is doing. If the parent state changes, it will render from wherever parent state was defined. All changes to the list were necessary would render from the to-do list. Yeah, okay. I see what you mean. It makes sense as long as your state dependencies are like going down or what do they call it? Top down. But you might have like in the list you have a to do that's completed true. What if parent state like depends on that? I guess that doesn't make sense. But what if you made, I think a better example would be, what if you made the actual to-do item a reactive as well? Because then the way you display the list depends on the state of the completed state of each item. But if each item is a reactive in and of itself, the only thing that's going to happen when you flip the completed toggle is that the to-do itself is going to be notified and re-render. But the list that's going to be filtered based on that completed state is not going to be notified. Ugh. Thinking. Yeah, just to explain. Yeah. So, but why didn't we write code? I got stuck on something. I wanted to write some code, and then I was like, how are we gonna solve this one? Was it a snapshot thing? Yeah. Okay, because the whole thing is like what's most important to you? I mean, this is a good question for you, Adam. What's it most important to you? Is it the technicality that when you make a change to the completed state, you know that only that to-do component that's actually observing that completed state is going to reconcile? Or is it the fact that you can just point to the completed state in your class and flip it, and then the UI magically updates? Because, as I mentioned previously, the problem now with React is that if you were to do a top-down flow of that completed toggle, it would reconcile like every fucking thing in your app. Like every component would be visited and reconciled, which is horrible because we want to lift our state very high, right? Here to the top level. Yeah. Yeah, I agree. Like there's something about but the most important thing is like being able to just work in a programming paradigm that's not part of the reconciler. You can just mutate stuff and the UI is kept in sync. And you know the technicality of it being very performant because it only renders the one thing that observes the value. But if and as I said, like currently all these components will reconcile when you flip that. Let's do, you know what, let's make this the to-dos example. Ah shit, I have a meeting soon I have to go to. But in this case, you flip the completed. If we notify the root about this change, it would like reconcile every single thing here. But with a React compiler, it wouldn't do that. As far as I understand the React compiler, it would actually just reconcile. And remember that each component is already optimized. So even though they reconcile, the reconciliation itself is optimized. Like that was just that was just pointed out, is it even caches like JSX. It just doesn't only cache state and props, it caches JSX as well. So like the reconciliation that needs to happen top down is so insanely efficient. At least it's the promise, that you wouldn't care about it as a performance issue. Because let's imagine, like, okay, we have 100% reconciliation in each component, right? That's how React works today. With a React compiler, it won't only remove like these unrelated components, causing this like gigantic waterfall effect. The components that's actually in the path of the change is gonna have like 50% reconciliation time. So it's kind of like two things that happens. But if you logged it, like if you did a console log in each component, you would see that when you toggle completed, that root and this and this and this actually would reconcile, right? So I guess this would be to-dos, like something like this. Whatever. Yeah. Though what bothers me is like is that memo of what if you just, the memo is like just making it an array, and if you toggle completed, it doesn't mean that that memo needs to change because it's still the same array. Right? So if you had a proper like reactive memo, it would actually, if you had a proper reactive memo, it would handle that. It is a different way. Like the whole journey here started with like, no, your state management shouldn't care about UI optimizations. But again, this is very annoying. Yeah, this is very annoying. But I want to play with it at least. I'm going to create a branch of Sponsify that instead of notifying components, it's going to... Yeah. Yeah. And like, again, React is designed to have a top-down flow of changes. So, yeah, so I think what's interesting about like doing this reactive thing as a short circuit, like you only notify changes based on like how you separate with using reactive is that that's kind of like what you're doing with components, right? You have components and then you use state within the components to figure out what actually needs to change. And that's the bad thing here, right? That's the bad thing. It's like we're trying, yeah, okay, this is coming through to me now. So Adam, the suggestion with reactive wrappers is like simulating the component tree. Or not simulating, but it's the same thing that the component tree actually does, right? Because each component can have a use state, and it doesn't matter, like, it's from, you can't like reconcile anything from above that, because you define the use state at a certain point in the component tree. And I think that's the thing that kind of, they had to like overlap with each other. And that's the bad thing here. It's like, if we do external state management and we're going to have this top-down flow, it literally means that React needs to reconcile from the top every time. While in only thinking React, you would probably put your state at nested levels in the component tree, and that way you wouldn't cause like a full reconciliation. And that is the power of mutable external state, is that it doesn't matter. Even though you expose your state at the root, only the actual component that has a change is going to reconcile. But then you lose memoization and like use memo and use effect. So it's like, yeah, as you say, there's a mismatch. They don't fit together. But yeah, okay, I have to go into that meeting. But that was really nice to have that conclusion, because that wasn't perfectly clear to me. And then there's just a question of, okay, with the React compiler, could you do a root-based reconciliation on your state? Like, is the React compiler so optimized that it's gonna make that path straight every time, right? And then within each component, the reconciliation is going to be so fast anyways, that even though it isolates the direct path, also the reconciliation happening through that path is going to be super optimized. And that's going to fix it, right? I think that's the thing we're going to explore. Yeah, that's the thing we're going to explore. Because if that's true, then the idea of like making Bonzified just a root signal that something changed, removing the references, and then it's gonna optimally render. And you can use it with use memo, use effect, and everything. And you can safely live in this mutable state management world, but you have the actual React primitives to help you optimize rendering. Yeah. Okay, that's the conclusion for now. Bye bye.